Hi, I'm Dr. Tim Floyd, Associate Professor of Mathematics at Georgia Highlands College, and this is one of our videos to help students with our College Algebra Math 1111 course. And this video is titled Introducing Relations. In this video, I hope it will help you to gain an understanding of what a relation is from the definition, and also understand that a relation can be represented by ordered pairs, graphs, equations, and other formats. So first of all, the definition. A relation is any set of ordered pairs. Now, the ordered pair is traditionally written in this format, and we have a parentheses with a comma separating two values, or two variables, or two expressions. And in this case, the first value, the first position, is referred to as the input position, and it's also the value of x becomes a value of what is called the domain. The second position is considered the output position, and the values of y that come in that position for all the ordered pairs in the relation are generally referred to as the range. Now, relations can be represented in several formats. Each format then leads to being able to create an ordered pair or a set of ordered pairs. So in this case, let's suppose we have a graph, and I'm going to take this graph and I'm going to graph a line. Now, in this graph, if you'll remember that the coordinate plane is set up in terms of the horizontal axis is referred to as the x-axis. The vertical axis is referred to as the y-axis. So if we select points on the graph, then we can make ordered pairs that will go with these values. Now, if we look at each ordered pair then, let's start with the lower one that I've made here. If we follow to write an ordered pair, then we would have a beginning parenthesis, a comma, and an ending parenthesis. And in this ordered pair, let's call it A. So let's give it a name, and then let us follow it. So we're moving in the negative direction, 2, 3, 4, 5, 6, and then we're going down to -3. So if we were to write that as an ordered pair, we would write it as -6. That was on the x-axis. And then we went down to -3 on the y-axis. Now, if we choose, let's let this second ordered pair be the ordered pair B, and we have parentheses, and then if we follow this, we're going to, and again in a negative direction on the x-axis. It looks like we're about halfway between 0 and -1 in the vertical, so we would then write this as -3, and then -1/2. That's about as close as we can get when we're looking at a point from a grid like this. We pretty much can get halfway. It's hard to get any more precise than that. And then our final point that we have, and we call it C, and then if we write it as an ordered pair with parentheses and a comma, then we will look at the ordered pairs. So here again we go, we're going to the right. This time we're going to +3, and then we're going up 5. So in this case, we would have +3, +5 would be the ordered pair. Now, for any location on this line then, we could ask ourselves, what is the ordered pair? So this graph is a relation. Any graph you make on the xy plane, we can get ordered pairs from. Now, suppose we have a table of values. Now, typically in this situation, I'm just going to select some values for x and y. So let's say we have -5 and 8, and let's say we have -1/2 and 2, and let's say we have 0, -1, and let's say we have 5, 5, And let's say we have 6, -2. This is typically, notice it's a 2-column table because we'll have 2 input values, which is the domain, output values, which is our y values. And so if we then write ordered pairs from this, we would have -5, 8, and we would have -1/2, 2. Let me finish that 1/2. We would have 0, -1, and then we would have 5, 5, and 6, -2. So any set of values where you can make a 2-columned table from, then we can make ordered pairs, and then of course we could take these to the graph and graph these if we wish. So the table then creates ordered pairs, or leads to ordered pairs, which does then make this a relation. It's a set of ordered pairs. Now, let's say that we have something that's actually generating. In the previous example, I just picked numbers. But let's say that we want to have something where we would actually make the values from. So let's say we have y equals 2x plus 1. So I'm going to use this equation then, and I'm not going to select values for both x and y because I'm going to select values for x. So let's say we do -2, -1, 0, 1, and 2. And then I'm going to sequentially substitute the value of 2, or -2 in this case, in for the variable x, and then we're going to calculate. So if I do that, so we have y equals 2 times -2 plus 1, and in this case we're going to get a -3. And so then if I proceed down the list, then we will have value based on each input. And then once we have these values, if we want to, then we could graph these ordered pairs, or we can actually write them as ordered pairs if that is what we desired to do. So in this case now we have, just look back through and make sure I calculated these correctly. Okay, and that's what you should always do also. Now we have the values that we want, and if we wanted to, we can now make these as a set of ordered pairs, and therefore this is another way, since this formula that we have used, this equation, we can now say that this is a relation because it creates ordered pairs. And our formula, and inputting these values of x, which I chose, led us to these output values. So each one was defined by the input value, the output value was defined by the input value, led us to making ordered pairs. So this equation, using x as the input and y as the output, led us to create these ordered pairs, which makes it a relation. All right, now I want to show you about how to do a mapping. Mappings are used mainly to help us visualize a relation, and it will also help us in the video, that if you watch the video on functions, you can kind of visualize how things connect in a function. Now in a mapping, typically what we'll have is we will have these ovals that actually, first oval, I'm going to put input values or x values into, and I'm picking these numbers at random at this point. So let's say we have -2, 1, and 8. And then in our output circle, I'm going to use the values of 5 and 3. And the mapping is created by drawing an arrow from one circle to the next to connect a number in the domain to a number in the range. So let's say that we have this. So the picture then is a mapping. Each value in the domain is connected to something in the y. And so from this picture now, we can create ordered pairs. I'm going to put them in the table first. And then once they're in the table, and I'm only going to use a few slots out of this table. Now, from the table, as we spoke earlier, we can create ordered pairs now, which does make this a relation. And the nice thing about the mapping is that it lets us see how numbers in or values in the domain are connected to values in the range. And this will be very helpful when we go to wanting to talk about whether this relation is also a function. So in this video, what we've talked about is the relation and ways we can view it. The definition has certainly been presented, and in this sense, this is the beginning point. We don't talk about relations as much because usually the very next thing we go to is a discussion of the function. And if you're looking at these GHC videos, you will see my video and maybe others where we talk about the defining of a function and various ways that they can be represented. So I wanted to say thank you and appreciate you joining me. And I hope you will look at our other videos, and I hope this has been helpful. Thank you and have a good evening.